guys, it's Easy as Pie here, and today we're going to be going over conductivity. So conductivity is a measure of the free charges in a solution that can transfer an electric current. So initially the definition seems a bit complicated, but basically what it's saying is conductivity is just a measure of the amount of charges. So that'd be our ions, and those charges can transfer an electric current or carry an electric current. So what type of solutions have high conductivity? Well, as we said before, a solution with a lot of ions is going to have quite high conductivity. So these include salts, strong acids, and strong bases. But why exactly do they have higher conductivity? Well, it's because they fully dissociate. So if we see a reaction including HCl here, we can see that all the HCl we add to a solution is going to react with water and it's going to produce ions like Cl- and H3O+. Similarly, with a salt, when you add it in solution, assuming that the solution isn't saturated, all of the positive and negative charges from the lattice are going to break off. So you can see you have your negative charges, Cl- breaking off, and your positive charges, Na+ breaking off. So strong acids and bases and salts will have high conductivity because they produce a lot of ions. However, weak acids and bases have low conductivity because they only partially dissociate. Now, if you notice here, this arrow shows us that all the HCl will be converted to ions. However, if you have a weak acid, something like ethanoic acid, only some of the ethanoic acid will react to actually produce ions. So how do we know if something is a weak acid or is a strong acid or base? Well, as we discussed before, weak acids and bases will have this equilibrium error. And that just goes to show that not all of the reactant will react to produce ions. And this means that there will be less ions in solution and you'll have a lower conductivity. So examples of weak acids include carboxylic acids, so things like ethanoic acid or propanoic acid. Examples of weak bases include ammonia. So strong acids or bases will have a high or a very low pH. So something like 1 or 2 would be a strong acid. And you'll notice the equation will have a normal arrow like this to signify that all the reactant we put in is converted into ions. So examples of strong acids are HCl, nitric acid, and sulfuric acid. Examples of strong bases are NaOH and KOH. So conductivity is a pretty common question when we do NCA papers. And so this is just a basic format to write your answer. So first we want to give the definition. So if you go back to the beginning of the video, we know that conductivity is a measure of the amount of free charges in a solution that can carry an electric current. Now you always want to start with your definition. Next, we want to ask ourselves, does your compound fully dissociate or partially dissociate, and why? Well, we have to identify whether our compound is something like a salt. In that case, it will fully dissociate. If it's something like a weak acid, it will only partially dissociate. And then we want to justify, so say for solution X, it could be a salt. Because solution X fully dissociates, there will be many ions in solution, resulting in high conductivity. Or if we have something like a weak base, we can say that because this only partially dissociates, there will be few ions in solution, resulting in low conductivity.